What is going on, you guys, and welcome back to the channel. In this video, we're going to be looking at the concept of Lambda functions, and then we're going to extend on that knowledge by looking at three functions known as map, filter, and reduce. Now, in other languages such as JavaScript and Java, Python also comes with this idea that functions, or there can exist functions that have no names. Now, what does that mean? Sounds weird at first. JavaScript has this concept of anonymous functions. In Python, we call these Lambda functions. Just sounds fancier, that's all, but they both pretty much mean the same thing. Now, when you hear Lambda functions, just think functions with no name. Now, let's first go ahead and create a function that just calculates the area of a rectangle. So we'll say area, width, and length, and return width times length, like so. Now, something like this can easily be wrapped into or easily defined as a Lambda function. Let's go ahead and do that, and then we'll look at the differences. So we'll first create a variable which will assign our Lambda function. So we'll call it Lambda area, and then we follow it with an equals and Lambda keyword. So you may see a highlight show up on that word on your text editor, and then we specify the parameters, so width, length, and then colon, width times length, and that's it. So this function or Lambda function here does the exact same thing as our area function, just with some slight syntax differences. So the first one is that we have this Lambda keyword, whereas with our normal function we have this def keyword or def. The other difference is that our Lambda function does not have a function name, whereas our area one has the name area. Our Lambda function does not, and this Lambda area variable assignment does not count. This is not the function's name. This is just a variable we've assigned this Lambda function to. The next thing is that we specified our arguments or our parameters just like we did with our normal function, and then we have width times length. However, with Lambda functions, you do not have to specify the return part, as this is kind of just inferred as the return value. So width times length. Let's go ahead and just check it out quickly. So we'll say normal area function, which is area and then 4 and 5. Take that. And instead here, we'll say Lambda area function 4 and 5. If I run this, we get back 20 for both. So, nothing unexpected or out of the blue. However, what I want to show you is the difference in terms of how Python registers the name of each function. So we'll say print normal area function name, and we'll say area dot underscore underscore name underscore underscore, and we'll take the same thing as, oops, it already printed it out. And then here we'll say Lambda area function name, and we'll say Lambda underscore area underscore underscore name. So if I run this, you should see now in my console below that the first one has the name area, which is true. We understand that because we named it area. However, for our Lambda function is coming back as this Lambda wrapped in these brackets. Now, you may be thinking, wait, why is it not saying Lambda area or whatever we write here? If I change it to that, we also get an error because, anyway, that was a bad move. But why does it not say Lambda area? That's because this isn't the name of the function. This is just the assignment that we make. And I'm sorry if I'm repeating myself, but just to kind of hone in on the idea of what a Lambda function is. Okay, so we can now see visually that Python does not assign a name to a Lambda function. Lambda functions have no names. The other thing to keep in mind is that when you define a Lambda function, you can specify as many arguments or parameters as you want. So in our case, we have 2, but you can do 10, 100, whatever you want. However, the one thing that you have to, or the only one thing that you have to keep in check is that it can only have one expression in a lambda function. In our case, it's width times length. You cannot add anything more to this apart from one statement. So when you're using a lambda function, or if you ever decide to use a lambda function, keep that in mind, that it can only be one expression. Okay, so let's actually put this to some good use by looking at three functions: map, filter, and reduce. So with map, let's first, before we actually jump into that, let's go ahead and create a list. So we'll say miles, and we'll just give it some values and 10. So this is a list of miles, and now we're going to see what the map function can do with this. So what the map function does is it takes an iterable, in our case a list, and it applies a function to each element. So for example, if you wanted to create a function that or if you wanted to map a list to multiply each element by 2, you can do that using the map function. But in our case, let's create something a bit more interesting, and we'll convert each of these miles into kilometers using the map function. So we'll say kilometers equals map, and then first the function that we want to use. So we'll say lambda, and then mile. So mile representing an element in this list or this iterable, colon, and then mile times 1.61, which is the rough conversion from mile to kilometer. Okay, now let's go ahead and print this out. So we'll say miles to kilometers using map, and then we'll say kilometers. If I can spell today. All right, let's give this a run. And yeah, I forgot one thing. So the map takes in 2 parameters or 2 arguments, the first one being the function, and then we of course need to give it the iterable to apply that function on, which is miles. So if I run this now, we get back miles to kilometers using map, and we get back a map object. And which is a bit weird at first, because it's like, wait, shouldn't we get back a list object? You may be expecting that. However, this doesn't, it just returns a map object. And in order to convert it into a list, all you have to do is wrap the map function inside of a list, which then takes this map and converts it into a list. Now, if I run this, we get back miles to kilometers, and we get each element being multiplied by 1.61. So our first one, 5 miles, being converted into 8.05 kilometers, and etc. Okay, so that's what the map function does. Again, it just takes an iterable and applies a function to each element. Now the next one is filter. And what this does, let me just name this as map. What this does, the name actually might be self-explanatory, but it just takes in, again, an iterable and filters out elements that don't or do match a condition. So let's go ahead and say we want all the even miles, and that will just be, again, filter. However, just like with map, we need to wrap this around in a list, otherwise it will just return back a filter object. And then we have to specify the condition. Now for this, we'll say we want back all the miles that are even, and to do that we'll say lambda mile, where mile modulo 2 equals 0, and then we have to of course pass in our iterable, so miles. Okay, next let's just print this out, even miles, and we'll pass in even miles. If I run this now, we get back all our even miles, so 8, 2, and 10. So you can specify whatever you want. You can say, give me back all the miles that are greater than 3, or all the miles that are odd, all the miles that, if you multiply by 2 equals 20, something like that. But that's what the filter function does. It just filters out an iterable that matches some condition. And now for the final one, which is reduce. Reduce does not come built in with the Python language. It actually comes with the standard library, so you have to import it. So back at the top of the file, you can import it by just saying from func tools import reduce. Okay. So with reduce, unlike map and filter, which returns back a map or filter object and then can be converted into an iterable, or in our case a list, reduce just takes a iterable and reduces it down to one element. So we'll say reduce. Now let's actually give it an example. So let's say we want to get the largest element, or the largest mile in this iterable. So we'll say maximum mile equals, and then reduce, and we'll specify our lambda. So we'll say lambda. Let me just shrink this actually because it's quite long. So lambda, and we need to specify 2 arguments in this case, as it will compare 2 arguments and make a judgment out of that. So we'll say mile 1, mile 2, and then we'll say that mile 1, if mile 1 is greater than mile 2, else mile 2. Okay, so what this is doing is taking each element, so the first 2 elements in the first iteration, comparing the 2, and then if it gets back, if mile 1, so if we look back at our miles list, we have 5 and 7. If mile 1 is greater than mile 2, so mile 1 first being assigned to 5 and mile 2 being assigned to 7, then return back mile 1, so 5, otherwise return back 7, which in our case is true because mile 2 is greater than mile 1. And then it will compare 7 with 3. Okay, then it'll stay with 7, then 7 and 8. Okay, it now switches to 8, then 8 and 2, and so on until we get back 10. So that should be our expected value. So we'll say print maximum mile, and we'll say maximum mile, like so. Now if I run this, we get back a new error, which is reduce expected 2 argument. Again, same mistake, long day. We need to give it the iterable we want to apply reduce on. So miles, which is this here. Don't know why I made this mistake. Very rookie mistake, but yes. So we have to also pass it the iterable. If I run this again, we get back our value, which is 10. And from our human computation, we know that that is correct. Okay, cool. So that pretty much sums up Lambda functions and also the map, filter, and reduce functions. You can, of course, check this code out on my Replit link, which I will add in the description for this video. Definitely play around with Lambda functions. They do look weird at first. However, yeah, like seeing it a few times, you kind of get the gist of what they do. They can look intimidating, of course, with this weird fancy Lambda keyword. However, all they are just anonymous functions, or functions with no names, that pretty much have one expression, which is the beauty of it, in that you just have to narrow it down to one expression. And we also looked at map, filter, reduce, 3 commonly used functions applied to iterables. Definitely useful if you're working with them in your day-to-day life. However, otherwise, I hope this video brought great value to you. Stay healthy, stay safe, and I hope to see you in the next video.